Hey everybody, Dr. Powers here. We're going to go through this tutorial. I'm going to show you how you can build a simple population in StatPowers in order to give it to a classmate, so they can sample from it and kind of use it for kind of exploring different concepts throughout this course. So we're going to follow this tutorial, and you may very well be able to follow it just from reading it, but I figured I'd show you this video so you can have a visual. So the population consists of undergraduates who are going to be participating in a study. So I guess what we would say is that the population is all undergraduates, and then the ones that are sampled are the ones that actually participate in the study. Let's see, there are three treatments. So some of them are given no special priming. Some of them are given some special priming that would with keywords that make them think about old and senile and things like that. And then the others are given priming instructions that have words like that promote intelligence, supposedly, right? And then afterwards, they're given a memory test. There's four variables we're going to be looking at, and they are we have the participants' gender, their treatment, their GPA, and finally the score they get on their memory test. So we're going to start by, so you want to go first to StatPowers, the population sampling simulator, which I'm already at. We're going to start by giving this population a name, and I'm going to name it the memory experiment. And as I said, there's four variables, so we can just increase the variables by clicking 1, 2, 3, 4. And I want to name these variables just in the same order, although the order doesn't really matter. Gender, which is categorical, the treatment, which is categorical, the GPA, which is going to be not categorical, but rather continuous, and finally we have the score they get, which is also continuous. So you want to set these up. None of these are going to be hidden variables. That's an option that it makes it so that the variable cannot be sampled, but it still can have effect on other variables, but we're not going to be doing any of that. So our variables are now set. We have variables 1, 2, 3, 4. They're named. We have their types. That's all we're going to do in this first panel. And so I'm going to close this panel because we're done with that. Now we're going to move on to the variable dependencies. Variable dependencies is how you can specify independent variables versus dependent variables. So we're going to be working in a simple situation where score is going to be dependent solely on treatment. We're going to be extending this in part 2 of the tutorial, which I'll record in a separate video. But here we're just going to set this treatment as the one dependency for score, and that's all I'm going to do here. And so now I'm going to close this up because we're done with that. Now we have to set the variable details for each of the four variables. Now you'll notice there's this yellow panel down here that has a bunch of errors. A bunch of my variables do not have defined minimum and maximum values, and as we go through, these errors are going to be sorted out one by one. But for now, we're going to just go and take care of the variables. Now, for the gender variable, we are going to have 3 categorical values: male, female, and other. And I'm basing this off of, so I'll set the values male, female, and other. Now, I looked at a recent survey in 2023, and roughly 22% of undergraduates identified it as other, and so I'll put that 0.02 here, and that means we're going to have 49% in each of these other categories. I'm going to just say an equal split male-female. It doesn't really matter because gender is not going to affect any of the variables in this experiment. So this is fine for the distribution for this categorical variable. We have 3 values, we have 3 probabilities, and they do add up to 1. So you notice that little error is gone now. I'm going to move on to the next variable, the treatment variable, which is categorical. We have 3 values, so we have control, the old treatment, and the intelligent treatment. So set the number of values to 3. and set the names control. We have old and we have intelligent. And I have not defined these probabilities. Now I'm going to actually show you later how you can do a stratified sampling where we can basically say I want to have say 15 from each of the groups exactly. So this is not going to matter so much, but what I'm going to do is I'm going to just have an equal split between these three. And an easy way to do that is just to set them all to 1. Now obviously these do not add up to 1, these add up to 3. So I'm going to click Scale Probabilities, which scales them down so that they do add up to 1. It's a nice little feature that can easily fix your distribution. So we have our treatment values, we have the 3, we can move on to GPA. For GPA, I looked at some data and I found this distribution. I'm going to try to match this distribution of GPAs going from 0 to 4. In fact, in this distribution, you can see that it only goes from 1 to 4, and it's left skewed. So to capture that, I'm going to pick a moderate left skew, and I'm going to set the minimum to be 1 and the maximum to be 4. And that is all I need to do there. I want to keep the precision at 2, so I get GPAs that are like, 3.27, for example. And that's, I don't want to have 3 or 4 decimal places. So that is good. I'm going to move on to the next variable, which is score. Now the score they get on their memory test is going to range from 0 to 10. So we have 3 different groups. We have the control group, we have the old group that are given old words, and then the intelligent group, so to speak, which are given intelligent words. Well, we're going to have use this feature called a discrete dependency, which is a different distribution for each of the 3. And so we have the default probabilities, which is going to be for the control group. So what I'm going to do is just set that to be a symmetric unimodal, which is going to be kind of like this bell curvy shape, with a minimum of 0 and a maximum of 10. Now, all the errors are gone now, but I still haven't finished because I have to add another distribution for the old and another one for the intelligent. So to do that, I'm going to click on this plus, which is going to add a condition. So condition 1 is going to be based on the treatment variable and for the value old. So this is condition 1. The default was control. Condition 1 is going to be old, and condition 2 will be for the intelligent. The distribution, I'm going to still use a symmetric unimodal, but for the old group, I'll have the minimum be 0 and the maximum be 9. So it'll be slightly shifted over to the left, or maybe squished a little bit to the left, I should say. And that's all I have to do for that. I'm going to add another condition, and that's going to be for the intelligent group, and set the distribution shape to be a symmetric unimodal with a minimum of 2 and a maximum of 10. This means that they are not going to be having scores very low. So I'm artificially forcing this experiment to actually have an effect. Whether or not this priming really works in real life is not the point. This is just an example. So we've now set the variable details and we have built the population. I'm going to close the variable details for the moment, and so we can just look at the sampling. Now, I'm going to just click on sample just to show you that this does work and I get scores for all of these. Actually, one little thing that I want to change, now that I realize it, is the precision on this last variable. I'm going to set it to 1. That's what I'd like to see. The precision of 1 decimal place for the score. Okay. Now, so I can generate samples. I can sample again and again and again and again. Every time I'm getting 30. Now, every time I'm sampling 30, everything is done randomly, right? I can set the sample size, but if I wanted to force it to have, say, 10 control, 10 old, and 10 intelligent, I can do that by editing the sampling options. I can set the sampling method to be stratified, and I can add strata. I can say the first strata is, let's say, 10, where the treatment equals control, and I can add another stratum, which is going to have 10 individuals where the treatment is equal to old, and then another one, say 10, where the treatment equals intelligent. And now when I sample, it's going to look the same, but if you count it up, you'll see you have exactly 10 of each. This is a way of simulating the randomized controlled experiment where I specifically randomize 10 individuals to go into each of these groups. And you can set these numbers however you want. If I wanted to have a certain number of gender in each group, I could add a condition, but I don't want to do that. The point was just to show you that the sampling works. So everything seems to work fine. I'm not going to do any analysis on this. What I'm going to show you is how to save this. Now, you can just click Save, but what I want to actually show you is this feature with this key. The key is a secret key that you have to unlock this to edit the population. I'm going to call this key Powers, and I'm going to just click out of this box, and it says the key has been changed. So if I save this population, a text file is going to be downloaded. That's fine. And what I'm going to show you next is what happens when you share the population. You'll get these two links. I'm going to open this link in a new tab. Now when I share it, that link, this link here, you can copy that and paste it, and your classmate can use that for sampling. And that's all they'll be able to do. When they come to it, they'll only see it in this form. They can see the name of the population, they can see the variables, but they cannot access the dependencies or the variable details. All they can do is set the sampling options and sample. They can get data. That's all they can do. However, if you wanted to come back to this and notice this lock, it's locked now. But I can come in and I know the key phrase is powers and hit enter. And now this has been unlocked. I can actually go in. I can edit the variable details and all that stuff. So when you share the population with your classmate, they will not be able to see any of the variable details. So it'll be just like they're sampling from that population in real life, basically. So we've saved it. In the next video, I will show you how to open or load a saved population, edit it, and we're going to add a linear model to it. But that's for the next video. All right, that's it. Bye.